Okay, so it's my turn. So, actually, I didn't introduce my department. I actually work for Google Nest, which is a hardware department. But of course, I'm a software developer. So, did you ever see this picture? Do you have any idea, what's this? Anyone? No, it's so this is the latest launched product of our department. It's called Nest Wi-Fi. So this is the Nest Wi-Fi point, and with a router, its small cute points will establish a mesh Wi-Fi in your house. And more than this Wi-Fi function, it also has our Google Assistant on it. It could be your music player and your smart housekeeper. Also, it can adjust the brightness of your lamp if you have those kind of smart lamps, and you name it. So actually, nowadays many of our hardware products, we have our Google Assistant on it, which encourage our software engineers, like me, to explore more about AI, especially machine learning stuff. So to talk about machine learning, this is such a huge topic. And I guess I have to raise today's topic, which is TensorFlow. Could you tell me how to switch the next one? Sorry. It's Romania, I can't understand it. Sorry. Could someone help me with how to switch to the next slide? Excuse me, sorry guys. Okay. Yep. Sorry for that. If I have a smart enough assistant, it will automatically switch to next slide for me, right? That's one thing machine learning could do for me, right? So anybody who work on machine learning, you can think about this and make that for me. Just kidding. So okay, next one. So I know this title is a little nerdy. Hello, TF Word. That's basically the first sentence you will write with your code, with your first programming language. So I'd like to share some of my views according to these 4 parts. The zero part, the first part, it's what is TensorFlow? And the second one is how popular is it right now? And how does it impact our real life? And the last one, but it's also important, which is how could we start it? Okay, so before the first session, I would like to take the opportunity to ask, how many of you have ever heard about TensorFlow? Could you please show me your hands? Wow, that's impressive, actually. So, how many of you did write some code with TensorFlow? Show me your hand. Cool. Okay, next question. How many of you consider to take a job which will frequently using TensorFlow? Or how many of you have already working on some TF project? Wow! Okay, so you come on, replace me. You should, you should take the place to give out your speech, your application. Okay, that's not humorous enough. Okay, so awesome. So first, what is TensorFlow. Let's take a look at this picture. Like we always say, talk is cheap, show your code. This is a typical learning example. People will start to write code with TensorFlow. So you can easily tell from the first line which TensorFlow is TensorFlow. But it's not just like Tensor and Flow. Like after you pip install TensorFlow, you can start it easily. And you can tell from the code, it's like basically constructing a model to train with some handwrite data. So this MyNest database, it's a famous database which stands for the Modified National Institute of Standard and Technology Database. I think it is. It's a large database of handwriting digits that is commonly used for training various image processing systems. The database is also widely used for training and testing in the field of machine learning. So, next one. So this is basically a history of the TensorFlow. I didn't include the latest TensorFlow 2.1, which is just launched in this year's Google I/O. So start from November 2015. TF open source announced, and it did its first release. And it's growing so fast during the past of years. And from my point of view, this two, So the Keras and TensorFlow this is two of my favorite parts, which makes it easier for us to work on it, as its API are easier to use and it's more scalable. So it's last November, I guess we celebrated TensorFlow's third birthday by taking a look back at the different components we've added through the years. Today, I'm going to talk about how TensorFlow has matured as a platform to become an entire end-to-end ecosystem. And TensorFlow 2.0 is the start of, I think it's a start of new area for TensorFlow. And we are committed and focused on making it the best machine learning platform for all the users. I guess some of you may hold different opinions, like PyTorch and Cafe, they are also good. But as I work for Google, I have to say so, TensorFlow is the best. So this is the screenshot of the GitHub main page of TensorFlow. You can easily see that the number of contributors is growing so fast. And even in Shanghai, China, which is the place I'm based in, we have TensorFlow clubs. And we also have GDG DevFest like this. And people from all walks of life, not just software engineers, also lawyers and financialists, they are learning TensorFlow, which is so much pressure for us. Okay, so if you want to learn details about TensorFlow, I would definitely recommend its website. This is the introduction from its homepage. It said, TensorFlow provides a collection of workflows to develop and train models using Python, JavaScript, or Swift, and to easily deploy in the cloud, on-prem, which is the abbreviation for primaries, which is on your own client, and in the browser, or on device, no matter what language you use. So Like this picture explains more about development. So we have so we know that it consumes a lot of like CPU resources when you are training models, and not all of us like have our own GPU sets or so. Like we provide some like TensorFlow Lite, and we provide some server-based in the cloud. We have some GPU already set for you, and you can just use it to train your model locally. So I'm gonna skip this part. So it makes you like more easy, and it makes the platform more like flexibility, and the performance it has a great improvement too. And like also I mentioned, it's more scalable. So this is some of the platforms we are supported for now. Like we have servers, we have device like your own phones. We also have TensorFlow.js. Oops, sorry. So like in order to make those real-world application reality, you must be able to take models from research and like prototyping all the way through the production. This has always been a core strength and focus for TensorFlow. Like using TensorFlow is like, as I mentioned, it can basically deployment on every device. So this is the second part. So how popular is it right now? So what's real usage do we have with TensorFlow? Like in May, I think it's 2013, Google released this search for personal photos, like giving users the ability to retrieve photos in their library. Like how many of you have the application for Google Photos? Wow. So did you notice that it will automatically like classification like your selfie and your friends, and also like some certain background like a palm tree, something like that, or your puppy, your dog? So how did this happen? So it's like this actually in our libraries, it's based on the objects present in the image. The feature, like later incorporated into Google Photos in 2055, and users no longer need to tag the photos with labels to categorize image content, like to emulating a manual task such as like managing set of hundreds and thousands of images, like to set of your own like sub-photo classifications. Like users could explore their collection of photos using search terms to locate photos with objects they might never have tagged. For example, they could search for like palm tree to surface all their vacation photos that had palm trees in the background. And software could potentially see like taxonomic designations that end users themselves might not be able to perceive, like distinguish salmons and absent cats, or effectively augmenting users like domain knowledge. So this was the example. So that's not my puppy. That's an example from the website. Yep. So we call this like it's labeling and it's tagging of the different photos. Like we will extract the different pixels from a specific like photo, and we use this. We call it neural network. So like image processing is image classification is the process of taking an import, like a picture like this, and outputting a class, like a cat, or a probability that import is a particular class, like, for example, this set of photos, 90% of it are cats, and others are like maybe dogs or something else. And you can like take a look at the picture and know that you are looking at maybe terrible shot of your own face, but how can a computer learn to do that? So this logic behind it is CNN, which is a convolutional neural network. So at the very beginning of the process, an import image is broken down into pixels, like not the phone pixels, it's real pixels. The main purpose of the convolution step is to extract features from the import image. The convolution layer, if you have some knowledge about it, the convolution layer is always the first step in a CNN. Let's say you have a flashlight and a sheet of bubble wrap. Your flashlight shines a 5 bubble multiplied with 5 bubble area. And to look at the entire sheet, you would slide your flash highlight across each 5 multiply 5 square until you'd see all the bubbles, right? So then it's a typical like first layer of a training model. I'm not sure if I make it clear because you guys are just stare at me and react nothing. So if you have any questions, like ask me, I will Google it for you. So this is actually, how do I play it? Come on. Okay, so this is actually a funny example, like the machine learning stuff, they can automatically like learn the pattern in a video or in the image. For example, I have a patent when I was in college, like I have write some code and detect a certain pattern, like to like draw a circle or like put some gestures like good, and the browser will recognize this pattern with its camera. And also I've got something like leap motion, those kind of hardware, like Kinect. Do you guys know about that? Like Kinect is the Microsoft Xbox, like the game. Yeah, so like it can recognize your gestures and it can like, you can define it. Like, because if when you recognize this gesture and the browser will open the home page for you, something like that. So this is now it's very achievable if you are using TensorFlow.js. We have like a lot of APIs which allow you to just call it and define it and make some funny application for it. And I have a colleague who like work on TensorFlow. He made some side projects, which is like he put a small sensor in a stick. We call it magic stick, like Harry Potter, or like some yeah. So it's some sensor in it, and we will collect some data from that sensor, and also there's an MCU inside it, and after like if you draw a circle, like we detect that pattern, and we will like turn on all the lights in the room, like make it like happen as a magic. Like it's a funny story, but it's the real thing that people are using TensorFlow and make those kind of applications. I guess if you have like explore a little bit about TensorFlow, all of you will have your own funny ideas. And like today, my purpose is basically to open a door for you, like take a look at TensorFlow, and I think like I will encourage all of you guys like make your own application with TensorFlow. Oh, okay, talk too much. Like the next one. So this is the second example that it's already happening. So it's word recognition. This is a typical handwriting ancient word, like we call this VSA. So the very first challenge with digitize the historical document like this is actually accessing the text, because they are mostly images, but not those kind of like printed characters. So traditional OCR, like stand for optical character recognition, technicals work well with printed documents, but there's still a long journey for us to fully understand these handwritten stuffs. So right now, discovery in VSA, it's a Vatican secret archive, is entirely manual. And we have a lot of like people learn history, and people especially like learn languages. Their goal is to like build tools to help scholars conduct large-scale and data-driven analysis on the content of historical archive like VSA. Like actually, we already have those kind of small applications on the web, but it's like not very decent or very sophisticated like we want it to be right now. So this picture like shows how high if we like put all the VSA content in paper. It's like it will have this kind of mountain high. So that's a large amount of it. Okay, so next one I'm going to talk about an example about hairs. This is a typical picture. Like this is a disease. We call it like diabetic retinopathy. Yeah, that's what the word is too complicated for me. Like it's if you have diabetes and you will have some blood point in your eye, and if like the doctor doesn't find it early enough, that could result in blindness. So this is I will consider it very serious disease. So nowadays, doctors often diagnose this disease by examining the image of like the lesion, the posterior lesion of the eye. As you can tell from the right picture, that's a typical like people have those disease, the picture. And ocular like bleeding and fluid leakage are the main criteria for determining the severity of this disease. And however, only experienced doctors and experts can scan and interpret these images. Currently, there's a lack of resources for doctors who can like diagnose this disease, which also puts many patients at the risk of blindness. Like this is a Google brand team, they made this happen. So it's a research team, they focus on artificial intelligence applications that works with doctors in India and United States to help them diagnose the disease. The team collect more than like 128,000 eye exam images from more than 50 doctors. And each image was evaluated by 3 to 7 experts. And these images are imported into an in-depth algorithm for creating an axiomatic, the predictions of an neural network algorithm of the Google brain. And it's to verify the performance of algorithm, the team will test a total of 12,000 test images on 2 different datasets. That's like GAN. Do you know the GAN? The adversarial neural network. So the predictions of this algorithm of Google Brain are very close to the actual results, and it is considered to be comparable to the diagnosis of an experienced expert, which will save a lot of people's eyesight. So I feel so moved that nowadays we can use our technologies to help people with this kind of disease. And so I would say if I have this kind of knowledge, I will also try to make my own contribution to it. So the word is the young generations. I hope you guys will cheer up and make something to it. So the application of machine learning in DR diagnosis is actually a breakthrough in artificial intelligence and health services. More accurate DR automated diagnostics can help eye hospitals evaluate more patients and optimize the treatment options. This technology could help to resolve the shortage of resources in such area. So, am I out of time? It's 45 minutes? Okay, so I will cut it shortly. So to start with machine learning, I think I have to talk about neural network. Neural network is one of the most popular machine learning algorithms at present. It has been decisively proven over time that neural network is outperform other algorithms in accuracy and speed, with various variants like CNN, RNN, auto-inheritance, deep learnings, etc. Neural networks are slowly become for data scientists or machine learning practitioners, which what linear regression was one of the static sense. It is thus imperative to have a fundamental understanding of what a neural network is, how it is made up, and what's its reach and limitations. So this posed an attempt to explain a neural network starting from its most basic building block, neuron, and later to deriving its most popular varieties like CNN, etc. The function used in a neuron is generally termed as an activation function. There have been 5 major activation functions. Not sure if you heard about it. So it's sigmoid and 10, and maybe I'm going to skip this part, maybe it's too detailed. So you can easily tell this is a typical network. So every neural network has one input and one output layer. We have two kind of neural network. One is supervised, another one is unsupervised. So the number of the hidden layers, sorry, it's too much. I can finish. Okay, so I got 30 minutes more. Are you guys tired? To be honest, this part is the tedious part of my presentation today. So, what I mentioned before, it's like, so in the middle part of the neural network, we call it hidden layers. Like for instance, differ between different networks. Depending upon the complexity of the problem to be solved, we will have like a different amount of the layers. So a neural network having more than one hidden layer is generally referred to as a deep neural network. Like convolutional neural networks is one of the most famous neural networks and used heavily in the field of computer vision. Like we mentioned the first and the third example, the image processing stuff and also the diabetes diagnostic, they are all like take advantage of CNN. So it derives its name from the type of hidden layers it consists of. The hidden layers of CNN typically consist of like convolutional layers, like and also pooling layers, like fully connected layers, and normalization layers. Like how can I explain it in real life words? To understand it in detail, like one needs to understand what convolution and pooling are. Like both of the concepts are brought from the field of computer vision, are defined as like convolution operates two signals, like or two images. Like on two signals, it's like 1D, and for like two images, we call it 2D. Does that make sense? You can think like one of the input signal or image, and the other called a kernel, also as a filter, if that makes more sense. On the input image, and we will like producing an output image. So, like convolution takes two images as input and produce a third as output. Did I make myself clear? Okay, so like we have a lot of articles from the internet, and so it's actually a long journey if you want to start like on machine learning. I'm not going to say must, but I think it's necessary. You need to learn some like basic algorithm and learn some basic knowledge about like what's a narrow and what's a like model, what is a layer, and maybe that's too much for today. So I'm going to call it like an ending. So like if you want to start it, I would definitely recommend you to explore some useful documents. For example, this was what I'm going to say. Like it's a code lab, and we have a lot of sycamore things from the TensorFlow homepage that you can follow. Basically, you can follow this code lab, like write down your code step by step and make your own application with TensorFlow. Even that you have no idea what's a layer, what's an arrow, but it just makes things happen, and you will like start to feel it's interesting, and you can like dig into it. So I guess that's all for my presentation today. Thank you for the patience listening, and thank you.
Thank you, Shery. I would have one question for you.
Oh, okay.
So I work a little bit with TensorFlow in the past, but let's give it together a selling pitch or something like this. So, which is, let's say, which is the funniest use case where someone used TensorFlow, and if you know the cases or from your experience, and which is the most unexpected use case for TensorFlow?
So I'm going to ask the first question. Like, I did something which is really funny, because this is actually it's not my own stuff. So I saw this project from GitHub. It was written by a Japanese guy, I forgot his name, and the application is actually a very simple training model that it's called like boss detection. Can you guess what the application did? So it's basically you take how many pictures I did? So I take 300 pictures of my boss, which is not my current boss. That's from my ex-company. I don't think it's the reason I left that company, but so I send out an email in my boss email box, and he clicks that button, and it's like automatically takes 300 of his face, 300 pictures of his face, and send back to my email. And then I have a model to train from these data sets, and to recognize, okay, this is my boss face. And what the application is, every time I sit in front of my laptop, and sometimes I'm not doing my job. Maybe I'm just see some movies, or yeah, you will also do that, right?
No, we never do that, no.
Oh, really? You are such
my
a
boss is in the
workaholic.
audience, that's why.
Oh, okay. So, yeah, maybe I got an interview from Google. That's not the proper content which could be see for my boss. And the application with the camera, it's running in the background, and it can detect the face of my boss, how many long is this? It's 3 or 4 meters. When my boss start to coming behind me, but I didn't notice that, but my camera knows that my boss is coming. So it will automatically switch my my page of the laptop into desktop. And hold on. I did some improvement of this application. So desktop is not usual. So after that, I switch it to a screenshot to my VS Code. with source code. Yeah, with actual code. Any of you like use VS Code? Okay, good. So that's I'm going to say one of my funnest application of TensorFlow. It's a simple application, but it's funny. And what's the second question? Sorry.
So the other one was the most unexpected use case, or the example that you gave also matches the unexpected part, but.
Okay. That's also a best.
Maybe something that, maybe something in medical or something impressive, maybe that it was made using TensorFlow.
So I'm actually not very clear about the unexpected application of using TensorFlow, but if I could imagine that, I think those people who take advantage of this like cut-edge technology and they use it to commit something bad, like you name it, like to tracking someone, some of your enemies, and commit a murder. Oh my God, that's awful. Like that's something I can imagine that we are took the technology like as a bad usage. Yeah. And actually, I really hope that we can use the technology to do like good things. Just as the culture of Google, it's like, don't be evil. So, but okay, I know why you guys are laughing, but that's the truth. Like we must believe, right? Yep.
Thank you, Shery.
Okay, thank you.